I think this talk is pretty much in line on the mainstream topic for this ValgrAI Symposium this year that we saw in yesterday's talks. That was what type of artificial intelligence systems we want to develop and what is our responsibility on doing so. So, you know, of course, artificial intelligence is everywhere. We all use artificial intelligence tools to make decisions at different levels. It doesn't matter if we use them just for translation, as Ramon said yesterday. This has important consequences. Maybe the translation is obvious, but we are missing nuances of language. Our students, all of them are using ChatGPT, Claude to write essays, to solve exercises, of course. And even worse, governments making use of these tools to make decisions on attacks or finances in terms of the banks, etc. So we are providing these tools with a lot of importance about our decisions, and most of them make value-laden decisions. But what we really know about the values that these systems promote or demote, how these systems are aligned with our value systems, with our morality, with our ethics, why they should respect our regulations. And the answer is nothing at all in many cases, because most of the systems, the mainstream ones, belong to private companies. So we are not allowed to see inside them and know about the values that they are promoting or demoting, for instance. And I use this term of values, and there are different definitions for values. When I'm talking about values, I talk about something that is more static and related to our human reasoning. For instance, a preference. You can have a preference for being rich, of course, but if you have a top value in your hierarchy to be fair, you don't want to be rich at any cost. So maybe you modify your preference because you want to promote value. So this is the background that we are interested on, and we endorse this Russell imperative. Stuart Russell from Berkeley says something like, AI must shift from intelligence to intelligence properly aligned with human values. But do we really have the tools to assess these human values in AI systems? This is the alignment problem, one of the main topics still unresolved. For this VSCF project. Okay, I'm working in the VSCF project. It's Engineering Value Awareness in Social AI. It's a project that is a coordinated project between the Artificial Intelligence Institute from CSIC in Catalonia, this university, BRAIN in this university, and this CETINIA research group of the Rey Juan Carlos University in Madrid. So I'm working with this team of people. I see some of them over here. And I take the opportunity to thank our brilliant PhD students, Anna, Isabel, and Jordi, who are the actual creators of some of the results that I'm going to show. Well, this project is an evolution of a previous project. It's an evolution of a previous project financed by the Spanish Ministry of Universities and Research. And in this previous project, we were more interested in taking into account human values to develop artificial intelligence systems that make decisions for us. And this is an evolution. Now we are most interested in assessing and be able to reason about human values and providing tools to assess the value alignment of these artificial intelligence systems in comparison with our value systems as humans. One of the sub-projects that is led by us is this sub-project 3, and it's about developing mechanisms for agents, humans, software to agree on collective values, to be aware of values, and then make agreements when we need to do so. So we are in charge of tasks related to value awareness and value agreement too. And we are using secure tools, computational argumentation, which is our main focus, but also cognitive theories. We are collaborating with psychologists, with sociologists, to develop theories and tools to be able to deal with these tasks. And this talk is about, this specific topic inside the project, how LLMs, how generative artificial intelligence identify, interpret, and reason values, specifically in natural language arguments. These are some of our current research lines. We are starting the project, started last September, so it's almost a year. And we are currently working on different lines of research. One line is pursued by our colleagues in Alcoy, in the Vertex Lead group, and they work to detect values in embeddings. So they use open source large language models and try to analyze how knowledge about values is present in specific embeddings, which layers on the network are activated when the system tries to reason about values, and what happens if we influence on that. I mean, change these embeddings and replace the specific embedding that gathers information about a specific value and analyze if the system changes its tendency to promote or demote a specific value. So we are trying to influence in the decisions of the system. Another line of research here in brain is that one, analyze the influence of cognitive bias in generative AI. So we did a research that was published in AMAS this year, and we tried to bias specific language models. We tried different large language models, and we tried to inject a specific cognitive bias via prompting, because again, we are working with closed models, so we cannot go inside the model. So it's something like telling the model to answer a question. For instance, this researcher is from this area, and the model provides you with an answer, and then we reply to the model and say, okay, yes, but from my previous experience, I think that this researcher is not in this area. It's from whatever. And we analyzed what happened with different models, with different models. And what happened? Guess what? They are biased. Spoiler, yes, they are. And they are prone to bias. Some of them very prone to bias, which means that models like DeepSeek were very easily influenced by the interactions with humans. They changed very quickly their decisions, trying to agree with us. So they are biased by this acquiescence bias. It's a cognitive bias that humans use in our reasoning systems. And this is not especially wrong. I mean, bias are very useful for humans. With bias, we can produce quick reasoning when we need them. I mean, we don't have all the times enough time to produce chain of thought like reasoning as models. Most times we need to produce a quick answer. So we use this bias and heuristics related to this bias to produce this kind of answer. So this is the way in which our brain operates. So the last one, the value agreement, the alignment problem, is to assess this value alignment between these models and humans in order to be aware to assess how trustworthy, how humans are these decisions that these models are making for us. Okay, so the core research question in this talk is that one: to what extent LLMs, a specific type of artificial intelligence, are aware of human values and agree with us when we are trying to identify these values, specifically in natural language arguments. So the task was to replicate an interesting research that was done in 2022. In this research, they produced a huge data set with a lot of arguments labeled with the values that these arguments promote. Okay, so it's a kind of a multi-level zero-shot classification challenge. In that research, a lot of human beings were used as annotators, and they annotated 44 human values related to these arguments. This is the hierarchy that they used. They used these 44 fine-grained values from this author, and they group these values into higher-level categories. One of them was the well-known 20 categories from the Schwartz values hierarchy, which is adopted a lot in our academic world of artificial intelligence systems. So in that research, they used human annotators, at least 3 annotators per argument, and they got around 0.5 Krippendorf alpha interannotator agreement, which means acceptable with moderate. But it's not bad taking into account the complexity of annotating 54 values related to a single piece of text. The annotation task worked like that. Humans were presented with this sentence. Imagine someone is arguing about this thing, with this text, with this conclusion, by saying that. And if you are asked why is this good, might this be their justification? Because it's good to have fairness, be individualistic, pursue universalism, etc. So, yes, this is a binary decision per value. Human values were merged using a well-known methodology, just not to select the majority vote, but the most reliable value from these annotators. And then they use that as a baseline, and they present the same settings in the experiment to different LLMs. These are the type of arguments that were used. You can check that on the slide and the presentation after, but I would prefer to focus on these results. This is our analysis. We replicate this experiment with actual and current large language models, not the ones from 2022, and key findings. The models were put in the same settings as humans, with the same sentence, with the same zero prompting, with the same arguments, and with an instruction. Normally, humans use 4 to 5 values to label each argument. And what happened? Humans, more or less, this is level 1 and level 2 arguments, which means 54 values, or second level, 20 Schwarz values. What? If you take a look on the image, what happened? Humans try to follow the instructions, and large language models first usually label a higher number of values per argument, and we have more layers where these models label much more values per argument that we do. So, cast a wider moral net capturing patterns, but what is really interesting for us was this result. They miss nuances. This represents over this set of 54, well, 53, I guess the image is cut, values for the arguments, which ones are labeled by humans or by LLMs with more frequency. And what we see is that in the y-axis frequency of LLMs, in the x-axis frequency of humans, look at that. The types of values that LLMs are easily labeling for arguments are something like biological, this is the red label, the red bubble over there, 45, which is just. This is for level 1, for level 2, just the 20 values from Schwarz. This is the result. The ideal would be to have all these bubbles in the diagonal. But what happens? Happens that models are over-predicting values like biological, be just, have equality, universalism, benevolence, self-direction, and under-predicting these socially grounded values, the ones that probably are more human, like be helpful, have success, be compliant, conformity, tradition, power, all that makes us more human. And we got low Cohen's-Kappa interannotator agreement, because this is a very difficult and complex task. So we try to do something to improve the performance of large language models as annotators. And what we try to do, we try to instruct them to be more human. We try to put heuristics and say, okay, these are the heuristics that humans make use to reason, to provide quick answers, for instance. And, well, what we tried was to inject these heuristics via prompting in 2 conditions. Condition 1, no heuristics at all. Condition 2, structural heuristics. And we analyze the performance of these models as value annotators, and well, the results were not very good as we expected, because we don't really know if they are making use of these heuristics yet. We try to inject heuristics, but probably these heuristics are already in the models. Next step, well, this is the type of heuristics we use, like representativeness, a mental shortcut that can produce stereotypes, so classify this sentence inside these values because this is something that is well known, it's a typical classification. Or availability. We have several examples, recent examples that classifies that as being of, or as belonging to that class, so shortcuts. Okay. New approach, heuristics didn't work. What happens if we try to inject biases in the prompts? So, using the same arguments that the original authors used in the study, first we try to classify which ones could present a specific cognitive bias, and taking into account these ones that can be classified as biased, analyze what happens with LLMs trying to annotate these arguments. I mean, is there any improvement for LLMs as human annotators when the argument inside presents a cognitive bias that we humans use when reasoning? And this is an ongoing work. We are just working on that. We still don't have any results to be published, but well, this is the type of bias we are trying to inject. For instance, confirmation bias. This is the one related to the bias I mentioned in the AMAS paper. I mean, the fact that we try to prioritize evidence confirming a pre-existing belief, try to get a confirmation from the model on what we really think. And well, we are just doing so. The arguments containing this bias, just different value detection results, we don't know. We are trying to advance research on that. And I think I'm running out of time, so this is our short-term studies. In the medium term, we will try to provide computational argumentation agreement mechanisms. Once we have the values detected, we will try to instruct the model to make an agreement with us about the values that we want to promote or demote. And in the long term, we will try to provide foundation models to reason about these values and advance research on these trustworthy artificial intelligence systems. Thank you very much. That's all.